Yoon Ha Lee is a trans queer Korean-American science fiction writer. He wrote the Machineries of Empire trilogy of space opera novels, which are basically novels where things blow up in space and the big characters have to solve all of their problems so that their ship doesn't blow up in space. In addition, he has also written many short stories, starting with the first one that he published in 1999 and continued to recent books that he's published now. In high school, Yoon-ha was interested in advanced math, but because of the stigmas against math, originally pursued a degree in history. When he went to college, he went to an advanced school in Korea, an international school, where he was exposed to advanced math a lot earlier than people usually are. So he was already reading books with complicated math in them that started to go above his head, but still intrigued him and he wanted to pursue them. He attended Cornell University and switched from history to mathematics, citing that historians are starving on the streets, and at least with a math degree, he will have a job. His main interest in school was abstract algebra. After graduating, he also completed a master's degree in math secondary education in Stanford, but his teaching career was short-lived because he started a family and has a daughter. He now writes full-time using his math background to add flavor to his novels and short stories, but don't worry, you don't need an advanced math degree to understand his works. The mix of math and magic is readable for all. He writes things that everyone can understand, and the math terms are in there to add an extra element and to integrate something that he is familiar with. He also makes games, like short tabletop game stories, and is very active on the internet and social media with creating content for people that integrates math and science fiction and fantasy. His favorite theorem is Cantor Diagonalization. Cantor Diagonalization is the theory that an infinite set of infinite rows of ones and zeros, so it's an infinite spread with each row different from every other, an infinite set of different rows can have the diagonal taken, and the value of the diagonal can be exchanged for the opposite, so the ones are switched to zeros and the zeros are switched to ones. And from this, you can create a row that is not included in the original infinite set. And the proof overall shows that not all infinities are the same size, because you can have an infinity and then have something that's not in the infinity and make a bigger infinity as a result.